it's so great to see Siemens at the show this year. Thank you so much for sponsoring and joining us.
You're welcome.
So I want to catch up with you a little bit. Can you tell me about trace? What is trace?
So trace is a technique for monitoring the activity that your processor is undertaking. The code is executing in a completely unintrusive way. So traditional debug techniques like setting breakpoints, halting the processor, there are an increasingly large number of use cases where that just doesn't really work anymore. If it's a real-time application, you can't stop the processor. If it's a multi-core processor, and of course there are more and more and more multi-core processors, and you're trying to debug some kind of interaction between the processors, you need to keep the system running. So trace is a hardware and software-based solution which allows you to collect the information about what the processors do without stopping it. And it involves using an encoder which will compress the information from the CPU about what it's doing, sending that off chip to a decoder which can then reconstruct the activity.
So it sounds like things have gotten more complex over time. Now, how does eTrace work here, and what is Siemens engaged in?
So eTrace is the efficient trace for RISC-V standard, and it was first ratified in March 2020 in version 1 that introduced support for instruction trace, and the second revision was ratified in May 2022 that added support for data trace. As the name implies, it's an efficient trace for RISC-V standard. It was originally developed by Ultrasoc Technologies, who donated it before. So Siemens bought Ultrasoc a couple of years ago, and more or less donated it to RISC-V. And yeah, as the name implies, it's efficient. You know, one of the problems about getting that trace information off chip is that you have limited bandwidth available. So the encoder's job is to compress that data, and the eTrace encoder will compress the data by somewhere in the region of 600 to 700 times. From the amount of data that the CPU provides, it will compress that down 600 to 700 times before you can send it off chip. And obviously, so the more you can compress it, then that makes it easier, more effective as a debug tool. You can either trace for longer, or you can trace more. You can be tracing multiple processors at the same time. And so that, that's a real advantage when you're trying to get your system to market. More recently, there is a new standard in RISC-V which should be ratified at the board meeting this week, which is the unformatted trace and diagnostic data packet encapsulation format. So this takes the output packets from the trace encoder, and it's defining the standard for how to encapsulate those for transport, as that was not standardized before. Though that's something which has been under development for the last year, and it should be ratified this week.
Thank you. So it sounds like more complexity, more efficiency. We're making new waves and new ground. So how is Siemens taking this into the marketplace?
Okay. So the trace encoder that we have is part of our holistic embedded analytics solution. So this is aimed primarily at shortening the time to market between when you get silicon and when you can release a product. It's you have very limited opportunities before you actually get first silicon to run your whole software stack and your application, because when you do that and it doesn't work properly, or it takes too long, or it consumes too much power, how do you figure out how to optimize that when you've got almost zero visibility? So what we provide is a set of IP that you can integrate into the design to give you visibility. So trace is one part, run control, traditional run control is another, monitoring for bus fabrics, logic analyzer functions, static instrumentation capabilities to give you as much information about what's happening in the chip as possible, so you can reduce that time to market. And we have a variety of mechanisms for getting that data off, be it over JTAG or USB or Aurora or over AXI to an on-chip system. And then the software tools to go around that. We have embedded and host-based software development kits to help you develop the software to both configure the IP and to monitor and analyze the data that comes out at the end. So really what that's aimed at is shortening time to market, which is obviously in everybody's interest. And that same IP can also be used once the product is in the field for collecting data, which you can use as part of a silicon lifecycle management solution when it's in the field as well.
Well, Iain, it sounds like whether it's time to market, faster debug, I mean, these are incredible solutions, and it's been really great to catch up with you.
It's been a pleasure. Thank you.